Hello and welcome to the terminal velocity revision video from scienceworksheets.co.uk. Please like and subscribe to support the channel. Terminal velocity is achieved when an object has a constant speed in one direction and the forces acting on the object are balanced. For example, we've got a ball here that is falling. It's got a weight of 5 newtons and an air resistance of 5 newtons that's in the opposite direction. So the resultant force on the ball is 0 newtons. However, in this case the ball is actually falling downwards, but at constant speed. Let's look at how terminal velocity works. The man is about to drop a ball. Once the ball is dropped, weight is the only force acting on the ball, so the ball will start to accelerate downwards, and the acceleration occurs due to the force of gravity acting on the ball. Once the ball is dropped, weight is the only force acting on the ball, and as the weight is 5 newtons downwards, the downward resultant force is also 5 newtons. And so the ball accelerates downwards and the velocity of the ball increases. At the same time, this will cause air resistance to increase. As the velocity of the ball increases as the ball falls, the air resistance has increased, and we can now see the air resistance is 2 newtons. This will cause the resultant force to decrease, and because the resultant force decreases, the acceleration decreases. So the resultant force has decreased from 5 to 3 newtons. However, the ball is still accelerating, so the velocity will still increase, but the increase in velocity will be smaller. As the velocity increases, the air resistance increases until it equals the weight. So at this point, the weight is 5 newtons down, and the air resistance is 5 newtons up. That means the resultant force is 0 newtons, so the acceleration will now be 0. And the ball is now at terminal velocity, so it's moving downwards at constant speed. We can represent the journey of the ball using a velocity time graph, which has two main regions, region A and region B. During region A, the weight is greater than the air resistance, so there's a downward resultant force that's greater than 0 newtons, so the ball is accelerating downwards. Also, during A, as time increases, velocity increases, so the air resistance increases, remembering that the gradient of velocity time graph is the acceleration. So as time increases, the gradient decreases, so the acceleration decreases. And finally, during B, this is when the weight equals the air resistance, so the resultant force, in this case, will be 0 newtons. At B, the ball is falling through the air at terminal velocity, because there will be 0 acceleration. Thank you for watching. See our revision notes for this topic at our website. Link is in the description.